Now we're doing FreeCodeCamp Legacy Python for everybody. Data visualization PageRank. All right, so let's get to it. Make sure you have your notes out. Not these ones. Oh no, save. That's what the deal was. Hold on, I gotta get my notes out. Those are the old ones. Boom. There we go. Get the notes out. Come all the way to the bottom. Right there. Let's grab this stuff so we can format it later. I mean, so we can use Python on it later. And let's drop this and turn this to a 2 and push play.
So now we're going to write a search engine.
I believe you. All right. So before we get into that, let's get this PageRank thing going on. Let's write this down. PageRank. PageRank. This is very important. Very important. We're going to write a simple web page crawler. We've done that before. All right. We're also going to compute a simple version of Google's PageRank algorithm. That's interesting, right? That's interesting, isn't it? That seems like a nice little stepping stone, doesn't it? We're going to visualize the resulting network. Okay. We're going to be in this pagerank.zip. So let's go open our thing here. OpenGeo. Pagerank.zip. It's got to be this file right here. It's got to be this one. All right. So let's come back over to the video and let's go.
Some of the things we're going to do PageRank, and we're going to visualize it in a web browser and show.
Hey, what's going on, Cyper?
We're really only going to do PageRank on one page because you want to have links that more than one page that points to a page so that you can fix it.
We're starting over because I do not know what he's talking about right now. All right, and go.
So now we're going to write a search engine. Do some of the things. We're going to do PageRank, and we're going to visualize it in a web browser and show the weights. Okay. We're really only going to do PageRank on one page because you want to have links that more than one page that points to a page so that you can figure out which pages are more or less important. And then we'll visualize it. We'll run the PageRank algorithm, and we'll separately do all this. So
all right, let's write this down before he gets into it. Oh, let's not make it that small, though. All right, let's do this. Search engine architecture. Let's see what this is. Search engine architecture. Web. Is this really the architecture? Crawling, index building, and searching. Okay. And what's this? Nothing. Oh, that's for this picture. That's a small picture. All right, let's go.
At this point, we're going to do pretty much the web crawling, the index building, and the searching. We're not going to really search it. We're going to visualize the index. But you could write a simple program to do searches for keywords and figure out which page was the most likely page for a keyword.
Back up. I don't know what we're talking about. Hold on.
More than one page that points to a page so that you can figure out which pages are more or less important. And then we'll visualize it. We'll run the PageRank algorithm, and we'll separately do all this.
Okay.
So at this point, we're going to do pretty much the web crawling, the index building, and the searching. We're not going to really search it. We're going to visualize the index. But you could write a simple program to do searches for keywords and figure out which page was the most likely page for a keyword.
Okay, when I said visual, whatever I said, that's the exact point where I got lost, and then he just kept talking. Give me a second. I got to come back to that.
In the searching, we're not going to really search it. We're going to visualize the index.
Okay, what? Visualize the index. Like 1, 0, 3, 7, index 48, which is actually the 49th element. Is that what he means? Who knows? Let's go. Okay, I'm going to clear my mind of this. Okay, I'm not mad anymore. I'm not pissed off. New information starting now.
But you could write a simple program to do searches for keywords and figure out which page was the most likely page for a keyword. And that would be a fun additional thing to do.
Did he just say that he's going to teach us how to get keywords? Because that's important. Because just coming up with them off the top of your head is kind of dumb. I always thought that's just how we did it. But if there's actually an algorithm to get keywords for us, isn't that important? Me neither. But like, because since I'm making this YouTube channel, right, I got to know about like keywords and stuff because it's like important to get people to watch my videos. But I just thought it was just thinking up stuff. So let's see what he's talking about.
So the web crawl.
Oh my God. All right. Before we get into that, let's write this down. All right. Web crawler. I mean, I know we've done a web crawler, haven't we? Anyway, web crawler. We know this, but we're going to write it down anyway. All right. A web crawler is a computer program that browses the World Wide Web in a methodical, automated manner. Web crawlers. Now, we haven't done this. We've just done page crawlers. We haven't done web crawlers. Web crawlers are mainly... Oh, let's drop this down. All right. Are mainly used to create a copy. Used to create a copy of all the visited pages. Hold on. For later processing by a search engine that will index the downloaded pages to provide fast searches. All right, what? All right. So it's going to index the downloaded pages to provide fast searches. Okay. That makes sense, of course. All right, so let's go.
Crawler is this program that hits a page, pulls down the HTML, parses the page, looks for links, makes a queue of incoming links that are as yet unretrieved.
All right, back up. Hold on, I gotta clear my mind again because he was just talking way too much. I wasn't listening. All right, let's do it.
Page for a keyword, and that would be a fun additional thing to do.
It would be.
So the web crawler is this program that hits a page, pulls down the HTML, parses the page, looks for links, makes a queue of incoming links that are as yet unretrieved. And I'm going to do this in a simple SQLite database. It starts out with, the database basically starts with one link as the starting point, and then it retrieves that page, and then you see the database end up with lots of unretrieved pages, and then it goes back in and picks a random page and retrieves that one, and then it just expands and expands. Hold
on. So does it crawl by going, okay, let's say it goes to Amazon, right? So it goes to and it sees links and it gets the links and it indexes the links. So is that how it crawls? It just goes from link to link to link? Hold on. We got to ask ChatGPT about that.
Code that.
Calm down. ChatGPT. Boom. So do web crawlers just go from link to link, harvesting the links in each link? So that's how it does it. Yes, that's essentially how it works. Web crawlers or spiders begin with a set of URLs, often called seed URLs. From these initial URLs, they fetch the page contents. Crawlers retrieve blah. They fetch the page's content, parse the page, harvest the links, repeat the process. Interesting. Now that's interesting. Now that's very interesting. Let's go.
I've built that you're going to play with is only stays on one website. Otherwise, it would go crazy. But of course, Google doesn't use an SQLite database running on your hard drive.
True.
But you'll get the idea. You'll see this thing exponentially gain links, and you'll run it for a while, pull down 1,000 web pages or whatever. But of course,
I got to think about that for a second. So the second you hit that, you make this thing going, it'll go crazy fast. Link to link to link, harvest, link to link to link. Crazy fast going to link to link. And it doesn't have to load the whole page. It just has to see the links in the HTML that it's parsing, right? It doesn't even have to load the whole page. It literally just needs to load a page of HTML, which is like nothing, you know? I mean, it's not like it's a graphic. It's not like it's a video. It's not like it's a sound. It's just some metadata. So I can understand you'd probably have to have a fat server for this thing, because the second you hit it, you probably got like a gigabyte worth of data. Maybe. I don't know. Interesting. Very interesting. Hey, look, that's exactly what it just said over on ChatGPT. They probably ripped it right off of Wikipedia. All right. No big deal. Let's get this in the notes. All right. So we're still in here in web crawler. We're going to retrieve a page. Read steps of web crawling. Yeah, that'll be good. Retrieve a page. Look through the page for links. Add the links to a list of to be retrieved sites. Oops. Sites, there we go. And then repeat. All right, makes sense. Makes sense. So the more that our page is linked to, the more important it is. All right, so let's go.
Make sure that you don't violate any terms and conditions. And again, I've got some data sources that you can use, and they're not rate limited, but you can also use things like Wikipedia, which I think they sort of discourage you, or drchuck.com, which has no rate limit, or who knows what, right? So just be careful. Don't do this on Facebook, and don't do it on Google. Don't get yourself in trouble. And if you're using, internet connection where you're paying for bandwidth, be careful. So this is the idea of the web crawler, and this isn't my picture. This is the classic picture of a web crawler. Read a page, parse it, take all the URLs and stick them in a queue, grab again and again. So for us, the scheduler is going to do it as long as you say, do 100 pages, or it runs until it blows up. I mean, and again, these processes that have the network in the loop, it's really important that they behave well when they blow up. And that's why databases are so useful, because you can be writing along to the database and some random thing happens and blows your data up, and you start over. So you're reading these things, you're storing each page, building up your storage, et cetera, et cetera. So you just keep on doing that. And with this program, you'll be able to retrieve some stuff, then run the PageRank, then you can retrieve them more, and then you can run some more PageRank, and you can kind of see how Google sort of evolves its index over time. Of course, we're so much simpler.
True. And all right, let's write this down before we get into it. This is really getting into my head, the possibilities. And then also not just the possibilities, but also the fact that we're so late. We're so late to this party, but it doesn't matter if we're late. We just have to power through, right? I mean, if they're trying to hold us back, we just have to power through, right? We'll find the crack in the system. We'll find the crack in the armor, and we'll push our way through. Because that's what we do. You know what I'm saying? I mean, so better late than never, right? So let's get this written down. Web crawling policy. Yes, right here. Web crawling policy. All right. So a selection policy that states which pages to download. This is a selection policy that states which pages to download. A revisit policy. Okay, there's a revisit policy. Policy that states when to check for changes to the pages. Are we putting commas after all these? I'm not putting commas on these. This is a bullet list. Dr. Chuck, I'm gonna miss your terrible, absolutely awful syntaxing. We only get 2 to 5 videos left of this horrible formatting. Oh man, aren't you gonna miss it? All right. Let's see. A politeness policy that states how to avoid overloading websites. Why capitalize it? Websites. All right. A parallelization policy. Okay. It must parallelize things. Okay. Whatever that is. I mean, I'm sure it makes things parallel to one another, but I've never seen that. Parallelization policy that states how to coordinate distributed web crawlers. All right. Oh, coordinating. Okay, that's cool. Why not just a coordination policy? I mean, whatever, doesn't matter. Let's go.
Like I said, be careful when you crawl.
Yes.
You're going to run a crawler that just goes as fast as it can.
Yeah.
But Google doesn't do that. It's careful not to overwhelm any websites. It's trying to be smart about the use of your bandwidth on your website.
True. Although I don't know why it would be how it could be so hard. I mean, like if you see a link and you already went to the link, you don't have to go to the link again. So how's that going to overload it? Like once you crawl every single page in one site, how is it bad? But I guess maybe some sites are like holding like multi terabytes worth of data, and Google doesn't want to like ram it. They just want to take like a few megabytes at a time. I don't know. We'll see. Robots.txt. Let's write this down. All right. Also, we didn't go through any of these policies, by the way. Robots.txt. Let's do it. Robots. I'm going to miss it. I'm going to miss writing down a whole thing and not going through it one time, or light brush strokes over an oil spill. A way for a website to communicate with web crawlers. Okay. An informal and voluntary standard. Make a spider trap to get spiders. Sometimes people make spider traps to catch bad spiders. Okay. What's this? User agent, whatever this is. All right, so let's see what this is. All right, let's see what this is.
There is a file our code won't bother looking at this.
Okay.
But there's a file called robots.txt that...
How much sugar has got to be in that coffee for him not to make a face? Every time I drink coffee, my face goes, yeah! Because I drink it straight up black. Because I'm fat enough as it is. You know what I'm saying? I'm not trying to freaking blow up drinking sugar coffee. Anyway.
Real web crawlers look at, and it gives a list of the things you are allowed to look at and not allowed to look at.
Okay.
And so if you go to Google and you see a search that says, we are not allowed to show you the summary text of this page because of the robots.txt, it's there. And you can go and you can actually see a robots.txt. Like on, just go to any website. It's at the top root, blah, 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 /robots.txt. It's not a path. It's not / this, / that, / something else robots. It's at the very, very top of a website.
Okay. Maybe we gotta. They never told us to do that in FreeCodeCamp. All right. Google architecture. Let's type this out. Google architecture. Sure. Okay. Web crawling. Index building. Searching. Okay. Let's go.
The index building uses the PageRank algorithm, and the whole goal of the PageRank algorithm is to figure out which pages have the most best links. So having the most links is really easy. You can just say how many links go to this. But the problem is you got to figure out the value of those links, and then you have to. How do you figure the value of those links? By looking at how many good links come to it. So it turns out that it's an infinite problem. It's an infinitely difficult problem to use PageRank. But you can approximate it, and what happens is after a while it converges to a reasonable value. And so we're going to run the search index, and each time it runs you're going to see that it says, you know, how much did these numbers change? And what happens is in the beginning they change very wildly, but quickly they flatten out. And it has the best way to think about the PageRank.
Hold on, man. Why did this guy do it like that? Oh, I just want to freaking go crazy. Man, I'm sure I am going to miss this horrible freaking style. The horrible style of Chuck Severance. Man, I'm going to miss it. Search indexing. I'm trying to give the man some time to talk, you know, and then he just skips the damn slide. Like, bro. Like, you're talking, I'm looking at your mouth moving, and then what do you think, I was reading the whole time? Of course not. Man, this guy. He is something else. All right, search engine indexing. Collects, parses, and does something else. Stores data. Stores data to facilitate fast and accurate. Ooh, that's not how to do it. And we'll just go to the next line too. Accurate information retrieval. All right. The purpose of storing an index. Let's shorten it up like this. Whiten it out like this. All right, so the purpose of storing an index, is to optimize speed and performance in finding relevant, we got to drop this down. In finding relevant documents for a search query. All right. Without an index, period. Without an index, the search engine would scan every document in the corpus, in the body of the page, in the page, in the site. Corpus, what is this? The whole body of the... Because I mean, Corpus Christi, Texas, body of Christ, right? So the whole body of... Is this the corpus, the whole body of the internet? Every dot in the corpus. I don't want to call it that. In the body. Let's put this to that. Which would require considerable time and computing power. Okay. Okay. All right. Now let's go forward. Chill. All right.
The way to think about the PageRank is think about how water runs, where you have a small little stream going by a house, and sometimes it rains, sometimes it's dry, and sometimes and there's like a little lake, and the stream is always running, and it doesn't go up and it doesn't go down. It might go up a little bit if it rains a lot, but in general, there's sort of a steady state, meaning that whatever water is coming in is about the same as the water going out. So we think about this in terms of web pages, the value of the links coming in.
That's not how freaking rivers work at all, or streams. I mean, I used to live right behind one. They go up and down, and sometimes they're dry. Anyway, bro, I think we get the point, though, what he's trying to make.
And is roughly the same as the value of links going out. So when that starts to balance the in and the out value from each of the nodes, then you've got pretty stable. And so what Google does is they have a really relatively stable assessment of goodness and value of pages, and they use that to compute PageRank. And then they throw a few more pages in, and it kind of has to adjust for a while, but it reconverges. And so this is a calculation that generally converges, and it doesn't vary wildly. And that's why Google's pretty good at kind of arriving at the true value of something. So let's take a look at what we're going to do in this application.
Is that true?
Again, we have a file that is going to spider the web, and we only have one database. Again, in this one, we'll have two databases in the next one. And so this is spider is the restartable part. And what we actually do is we put one URL in, the starting URL, and then spider walks in and asks, are there any unretrieved pages? And it does that randomly. It sort of picks among the unretrieved pages and says, okay, great, I'll go retrieve that page. And then I'll parse that page, and then I'll put in a bunch of new unretrieved pages, as well as the text of that page, and then a bunch of unretrieved pages. And then it'll go back up and it'll say, oh, give me one of the randomly non-retrieved pages, and it'll grab a next page and pull that page down and then add to it. And so this is like, there's a page and then a to-do list. And then this one becomes a page and then adds a few more things to the to-do list. And so the to-do list, or the unretrieved URLs, grows very rapidly. And the retrieved ones grow sort of as you retrieve them one at a time. But you've always got this long list. If you have a really short site that only has like 2 links, if you start at drchuck.com/page1.htm, it'll go to page 2 and then go back to page 1, and it'll be out of things. It'll have retrieved all of the pages. And so if you have a website that has no external links or has very few pages and they point to each other, this will run out of things to do. But if you go to a page like my blog, or the code that the sample stuff that I have up for you to spider for testing on drchuck.net, it'll run for a very long time, and you'll have far more pages to retrieve than pages that you retrieve. But that's okay. At some point, you can stop this. Maybe it stops because you ran out of bandwidth, or maybe your computer went down, or who knows what, right? But it's okay. This is a restartable process because it always has some pages that are retrieved and some unretrieved pages. True. Picks randomly from the unretrieved pages. Your database is the sort of persistent state of your spider, rather than a bunch of dictionaries or lists inside the Python, which go away when the program dies. And so at some point you have, let's just say, a few hundred pages in here and a few thousand unretrieved pages. You can run the PageRank algorithm. And what the PageRank algorithm does is it loops through all the pages and figure out which pages are linked to which pages, and then reads the numbers and then updates the numbers, and then does that some number of times. And so this is where the numbers, all the pages sort of start out with goodness of 1. I think this printout is showing that goodness of 1. And then it changes. And then the goodness goes to, some of the goodness goes up to 2, some of the goes to 7 and whatever. But then it does this over and over, and then it uses these numbers, and then they change again. And so there's a number of time steps that this PageRank runs.
It just counts.
And you will see, as the PageRank runs, when I show you the code, you'll see the average sort of change in these numbers across all these things, and you'll see that the average goes down very rapidly as you get through. And so usually with a few hundred or even 1,000 pages, like 100 plus times running this algorithm, and these numbers have converged.
Okay.
And that's what
all right. I've had enough of this for just a second. I got to take a break before this guy explodes my mind with his jargon-filled rant. Okay. So basically, at this point, it's getting to a point. I mean, I've kind of understand what's going on right now. We've got this thing, and they're just slapping a count in. But now he's talking about averages, and I'm like, what the hell are you talking about? Averages? Average of what? Average of what? And okay, so when I heard that, and he just kept going after we get lost. Obviously, he doesn't know we're lost, so he's just going to keep rambling on and on. Fact is, whenever we actually need to get into PageRank, we're going to need to actually take a course or read something for real about it, because this little crash course that he's doing right now, I'm crashing, So let's just listen to the rest, and hopefully we can make some sense out of it. I'm going to back it up just a little to something we've already heard, so we can get anyway, let's go.
As you get through. And so usually with a few hundred or even 1,000 pages, like 100 plus times running this algorithm, and these numbers have converged. And that's when you sort of can begin to trust the numbers. Now there's this one program called SP Reset, which sets all the pages back to 1, so you can start this over.
Okay.
So if you were to spider for a while, run SP Rank for a while, play around, and then you wanted to spider some more and start it over, you could say, oh, let's start the PageRank completely over. Or you could simply take the new pages and watch it adapt. Either way, this is just a way to reset all the pages to have sort of their initial value of a goodness of 1.0. So at some point you run this. This part here runs really slow. This part runs super fast, like in the blink of an eye. This one is pretty fast. And then at some point you've got these pages that have, numbers on them. They have values on the pages. And there's a couple of programs that allow us to visualize that. One is the dump, which just reads it and checks to see. It shows the new PageRank, the old PageRank, and various other things, and shows just a way to dump it. And then there's this thing that reads the whole thing. You say, I'd like to do 25 of the top, the best. It sorts it by PageRank, and then produces a JavaScript file that has just the numbers in it. And then there is some HTML and a visualization library called d3.js, which you can read about, that when the HTML starts, it reads this and has this nice force-directed layout of the PageRank. And you can hover over things, and you can see what PageRank you've got. And so that is the PageRank algorithm that we're going to do. And up next, we'll do the largest and most complex of these things, and that is the email. We're going to spider some email, which is about 1 gigabyte of data. Okay?
Why did he look? What was that look?
Spider some email, which is about 1 gigabyte of data.
Is it? Okay. Is it because he knows? Is this look because he knows he was filling us full of crap? Or did his wife just die? What is the answer? Put your thoughts in the comments. Honestly, why is he looking at us like this after he just completed a hard day's work? Isn't this the look of something else? I mean, I'm not 90 years old. I can't just figure out what a 60-year-old is thinking by looking at him. You know what I'm saying? I'm not there. I can figure out what a 20-year-old is thinking just by looking at him. All right, easily, because that's how that's worked. But I'm not 90 years old. I don't know, what is this look about? I don't know, but it's pissing me off. That's what I'm trying to say right now. If you saw my face, you'd be like, that man is visibly perturbed. Anyway, so there we go. Thanks, Dr. Chuck. one more video. How does PageRank algorithm work? It determines which page are highly connected. It figures out if ranks based on view counts. Nope. It figures out which page contains the most important content. I think it's this one. It feels like it's this one, but it might be that one. It is this one. All right, there we go, and submit it. All right. All right, so we're getting on to this. All right, so just to let you know, I decided we're gonna do all these only in the live stream because I'm not gonna record these. It takes too long and it's too confusing. And sometimes some of them don't even work. That's the thing. Some of these don't even work. I mean, in the past, I don't know about these, but there's a chance because in the past they didn't work. There's a chance these don't work either. All right, so there we go. So now we're on to data visualization, mailing lists, and we'll see you next time.